Hi, this is part 2 of a Toxprints set of videos. Please look at part 1 if you're not familiar with the Toxprints functionality. I am here in the Abstract Sifter. I'm in version 9, Toxprints. Most of what I'm doing here is also possible in version 8, but if version 9 is out, go ahead and download it. So I was playing with these chemicals. I'm going to go ahead and clean this off, although you don't really have to delete this, but I'm cleaning off the Toxprints. And I'm going to clean my chemicals out and start fresh. I curated some chemicals off of a publication here by John Gamble and colleagues, the DevTox Germ Layer Reporter platform. And this particular paper has some chemicals in it that they use as reference chemicals that are known developmental toxicity toxicants and that are not. So the ones means, and the red here means that they are known developmental toxicants, and 0 means they're not. And they use this list in this publication to predict other things, other chemicals. So I'm going to copy this list of chemicals with their endpoints to the Toxprint sheet. And the endpoint is not in the correct place. It needs to be over in column D, so I'm just going to move that over, which you can easily do with cut and then paste. Okay, there it is. And my color came through as well. Great. Okay, now I can get my Toxprints, and you can go ahead and get this, put the smiles here. The smiles is required for Toxprints. Although I think I wrote it, so if you don't put smiles in, it will go look up smiles for you. The Toxprints, to give you a little background, if you haven't looked at version or part 1 of this video series, Toxprints are simple structural features, 729 of them that can be used to do things like I'm doing here, to analyze patterns in chemical structure and how they relate to the activity of those chemicals. And I'm warning you that none of what I'm doing here is predicting the toxicity or not of a chemical. I am merely showing you some information. Use it with discretion. You can read more about Toxprints at this US EPA cheminformatics modules website, and they have links to the publications, and here in the Abstract Sifter README page I should have links to. So there are my smiles. Now I can go get my Toxprints. And I'm just actually selecting rows here. I could select any of these columns. I'm going to click on this button in the EPA custom ribbon, which I might rename to AS for Abstract Sifter. Just click on Get Toxprints. Fills in the headers, and then for each of those Toxprints, and for each of those chemicals, it's going to fill in a 0 and a 1. 1 meaning it does have that chemical does have the Toxprint, 0 that it does not. I'll pause this. Okay, our Toxprints have been retrieved, although it's hard to say it. It's hard to believe it because there are no 1s here. But if you scroll to the right, you start to see that there are 1s. It's a very sparse matrix and therefore hard to look at. So one of the things that the Abstract Sifter can do is you pick a chemical that you're interested in, and you can sort columns by that chemical. It will take that chemical, put it in row 6, and then sort these columns so you can see which Toxprints belong to this chemical. You can kind of read the names here. They're a little bit hard to understand. If you want to see them, you double click and it will actually go retrieve that Toxprint for you to a website. The other thing that you can do to see structurally what's going on here is take the name of the chemical or something, one of these identifiers, and go to the EPA here and put that chemical identifier in, and it will show you all the Toxprints visually. So this particular chemical has Toxprints 37 through 679, and it looks like there's 10 of them. And here they are, 37, 679, and they're about 10. So that's how you can go make yourself feel better about the Toxprints that are being returned to you. And the other video that I just did, I showed you how to sort and buy some other things. Please go look at that video. So today what I'm going to do is show you what I call soft prediction. It's really just building neighborhoods out of Toxprint's features and seeing where the chemicals fall. So remember, we have this endpoint here, zeros and ones. These are reference developmental toxicants, and these seem to have no developmental toxicity. Again, I refer back to this paper. Go read there for detail. All right, so to get an idea which Toxprints are more associated with either the negatives, I'm going to call these the negatives, or the positives, I'm going to go over here to this button and calculate endpoint enrichment. And what that does, it looks at the zeros and ones in the endpoint, and then it looks at the zeros and ones in the Toxprints and finds which of the Toxprints is more associated or more enriched with a particular endpoint. It gives each Toxprint a score, and then for each chemical, it sums that score into the feature enrichment score. There's more detail on this in the version 8 user guide. So when I sort by this enrichment score, I ought to have some kind of discrimination, segregation, some hyperplane going between the toxicants and the non-toxicants. So, and that seems to be the case. We have the toxicants here at the top, with the exception of ketanserin, which is a negative, stuck right in there among the other toxicants. And then as we go down, it's pretty clean, and then we start to see a breakdown where the Toxprints are not able to discriminate cleanly between the positives and the negatives. Then as we go farther, we see more and more negatives, and with a couple of exceptions here where there's some, I don't know if I can call it noise, but what's happening here is the Toxprints are not able adequately to draw a hyperplane between the positives and negatives, because you're getting some negatives down here with some positives down here with the negatives. Now you may think, well, okay, so let's look at some of these exceptions. Here, for instance, ketanserin is right next to ritanserin. You guess maybe they're similar. So let's take a look at some of these chemicals and see what they look like structurally. So I'm going to select these rows by selecting these columns, and then click on tiles, and I want to colorize with column B. All right, so these are developmental toxicants according to this publication, and this one is not. So interesting. What does that tell you? I don't know. But it's interesting. It's the sort of thing you can find out using the Abstract Sifter Toxprints. Here's another thing. So these, let's go down to the real negatives here, negatives, and look at this group and see if we can figure out anything there, why we would colorize the column B. Yeah, so this is the negative. I mean, this causes developmental toxicity according to that publication. This does not, according to that publication. They look very similar. So lots of interesting things there. Either our algorithms, either we haven't observed the right things, or we don't have the right data to make a clean discrimination between positives or negatives, and every algorithm has some noise in it. But we get some insight. That's the main thing. We get some insight, and certainly the larger your data set, the better the insight's going to be with this kind of statistical measurement. The other thing, again, this is, I think I've shown you all the new things about this. Well, no, that's not true. You can also predict something. So let's take this out. Let's just take out the one so it'll be ignored. And I'm going to make this yellow. Took out the one, so the algorithms are not going to treat this, are not going to even include this in the feature enrichment. It's calculating new feature enrichments without this chemical. And then when you sort it, the 6-propyl-2-thiouracil is indeed sort of stuck with its neighbors, and so if you're predicting this, you might predict it to be a developmental toxicant. Let's take one of these negatives, just pick one that I don't know anything about, sulfasalazine. Okay, let's take that out and recalculate the endpoint enrichment. And find sulfasalazine, and indeed it is among the negatives. So that's what I call soft prediction. It's just sort of looking at the structural features and finding what neighborhood a particular chemical is in. Okay, that's all for today. I try to keep these short and I tend to talk too much, so I'm going to stop there. If you have any questions or you need a different kind of video or more detail, please let me know. Thank you.